We have discussed yesterday about, we have started the chapter yesterday, the motion, chapter number 8, is it? In chapter number 8, ninth class, we'll study, not study about the, means deeply the motion concept of, means analytical part of, will not study about the motion. Here we'll discuss the basic concept. Basic concept means what the motion is, and motions variable, simple definitions of motions variable, and numericals related with these, right, aspects. So first we'll go with that slightly 5-minute revision we'll talk about. First we have described about the motion, what the motion is, okay, and I gave a illustration yesterday, an example. When you say the object is said to be in motion, I'm standing here. When after some times I will just stay here, then you will say I'm in motion. Is it here? Why? Because you are watching me and my surrounding things, sound systems, screens, and white screen and black screen here, right? At the same time you are seeing along with me my body, you are saying that I'm in motion. Is it here? But if these things will not change with respect to me, then you will not say I'm in motion. Is first thing. Second thing, I'm staying here, but my background is moving. Then again you will see I'm in motion. The same concept is used in picture motion. Is it here? Actor sitting in the car, right now the car set in the vibrations by somehow, right, anyhow, and thus they just shake the steerings and move their hands on the steerings right now, and backgrounds actually moves. The same situation or scenery movement are created for the observer. Is it here, no? Or audience? So this is the motion here. So motion does not need the object is absolutely to be moved. Is it here? So what we can say about motion? When do you say an object is said to be in motion? So an object is said to be in motion. You can write the definition. Have you written the definition yesterday? An object is said to be in motion. An object is said to be in motion when it changes position with respect to surrounding. When it's said to be in rest, when it does not change its position with respect to surrounding, then it is said to be at rest. And second thing, absolutely object cannot be in motion. What the word absolutely cannot be in motion? The example I am repeating this. You and your friend is sitting in the train. Is it here? Inside the bogie, right? You and your friend both are sitting here, that. Is it? Both are sitting in the same bogie of the train. Right now. You look at him and he just look at you, right? And both are appearing to eat for each other's at rest. Right now, still the train is in motion. The entire train is moving. You are in motion, your friend is in motion, your train is in motion, but you seem that your friend is not in motion. However, all three are in motion. Is it not? So is motion absolutely existing, or can we speak motion is absolute term? No. Another example also I gave you. Another train just come and reaches it near you right now, and you just see that whether the train approached here, and after some time the train starts moving. Then you just see that you seem that your train is in the motion here, and you could see right side there, and after some time you get relaxed. Yeah, my train is not in motion, that is in motion. Is it here? What actually happens and what you have seen here, that you could predict your motion, your train is not in motion. You see here the right side, the tea stalls and the passengers and the grounds and a lot of passengers and other objects are not changing their position with respect to you. That's why you could predict I'm in non-motioning. The second train that's approached is in motion. Is it here? It means motion is absolutely when your surrounding changes position with respect to you, then you seem to be in motion. Is it? This is absolute motion. Motion is relative, not absolute. Is it here? And three things are important for explaining motion. First thing is what? The first thing is what? Reference point, point of reference. The second thing that says object, and the first is object. Is it? And second, point of reference. Point of reference. Frame of reference will speak here. Frame of reference. Frame of reference. And third is what here? Viewer. It's viewer. Object, frame of reference, and viewer. Is it? What is object? Sir, that is a motion. That is an object. And what about the frame of reference? The things around it you are just observing is called that frame of reference. And what about the viewer? Viewer are those who are seeing you, who are watching you to be in motion, to be at motion. Is it or not? So three things are important here. Here in case of train, you is an object. You are an object. Your friend is viewer, and inside the train is frame of reference. When you stand outside the train, your friend does not appear in motion. Why? Because you are being seen, or your friend is watching you, observing you with the platform. His frame of reference, your frame of reference for him has been changed. Is it? That's why you are observing him, your friend, right now in the motion. But when your friend is in the train, then frame of reference get changed here. That actually he is standing on the same frame of reference. Is it or not? That's why you are at rest. So this is the thing important here, save in case here. So let's come on to that here. All the things we have discussed yesterday. Second thing, if there is a space, no objects are there. The trees are not here, the ground you could not see here that. So which you will make as a frame means object will change its position with respect to what? Will it change with respect to tree? Here it is a tree, okay, and an object is at here, boy is at here. Obviously it's going away from that. So this object will be taken as a reference point. This will become a reference point. Object will move away from that here. After some time its position will be at here. Got it? Here it is that here. And after some time it's A, or here will be what? B. So its initial position is represented as XA, or here it is XB. After some times it will be at here this again. Got it? And its position again getting changed here. Continuously one by one its position getting changed. But what about the here tree? I have replaced here. There is no tree. Then what you will make as a reference point? Exactly. It's a time. So, but however, reference point is always to be taken here. This. So object is at here and its surrounding frame of reference is getting changed. Then you will see this object is in motion. Okay, let's come on please. That is, so I have talked about the vector and scalar also, right? An example I gave you, a former start, right or not? There is spherical field here. Just former comes here closer to that and start journey from one end of the field. Is it here? He starts journey from here. The length of the field is here 10 meter. He goes from A to B, B to C, and then again C to D. Right? After C to D and again back to A. After one complete revolution, is it? What about the object distance? Tell please. What about the distance traveled by the former? Obviously, he has traveled the distance 10 meter along this path and 10 meter along this path, right? And similarly 10 meter along this path. Entire throughout the loop, he has traveled the distance 10, 10, the length of path, that is 40 meter he has traveled, length of path. Is it? But what about the displacement? What about the displacement? His displacement is 0. So what is the definition of displacement here that we discussed? The displacement is initial position is what here? A. And what about the final position? Sir, it's again A. So can you tell me the change in initial and final position? Yes, sir. When the position is same, here will what? 0. So change in position is said to be displacement. Not only same in case of that here. Suppose that this former is traveling from here A to B and after that C. Is it? Here just reaching at here. Got it? So what about, wait on please. Here from A to B 10 and B to C 10 and stops here. Then what is the displacement and distance of the former? Former start journey from here or he just reach at here. So tell please, what is the displacement. So distance is what? Length of path is the distance. And what about the displacement? Displacement, direct line you will draw here from that. Is it? So this length will be the displacement. So how to find out displacement? What type geometrical situations you are seeing that here? The geometrical situation, it's a 10 here or it's a 10 also here. But you are to find out the distance from here to here. So how one can find? Obviously this is called hypotenuse. This is called hypotenuse. And these two are perpendicular here as it is. So by Pythagoras theorem, is it here? Here we'll write by, obviously, therefore A to C. So displacement from A to C. What will the displacement from A to C? Here will be AB square plus BC square and under the root. Can you tell me why this would be taken as under the root? Tell please why. Its answer is by Pythagoras theorem. Is it or not? And after calculating that, you can find out this. How much is this, please tell me? This is 10 of a square. This also 10 of a square. So here we can write 2 times 10 of a square. And the term which is having a square could be taken as out of the root and here will remain as it is. It's a meter. This is the displacement of the object from A to C. By writing the value of root 2, you can calculate further. It's a 1.414. So multiplying 10, this decimal point will shift one position. Is it or not? It is this here. 14.14 meter. This is the displacement. So by solving numerical, you can understand the concept of distance and displacement. Not go with that chanting of the definitions. Simply we have learned that the change in initial and final position is called displacement. Displacement is vector quantity, distance is scalar quantity, the total means just you go with numerical approach. Is it here? If your answers are not coming numerically true, means your concept is not clear. Got it? Now proceed here. So some numericals will solve here. Keep open the study note, please. Do you have this study material? I have sent a soft copy online right now. You can just keep open that here. Now let's come on, please. Some numericals. Here it is. This class assignment I gave you to this. See that what this question is saying here. We have solved this question again here. Imagine yesterday you left your house at 6:30. Is it? AM for your school. After completing the journey 3 kilometers, you found that your school was closed. And one thing I also saying you that whenever you are solving any numerical question or mathematically, think the situations graphically. Means you make the picture of the problem. Imagination, no. Picture of the problem. Picture of the problem means it is this here. Third number. Here your home is there. This is home. You just go to the school. Obviously, school is not in the straight line like that. I have drawn here on the board here. It could be here just like here it is your school. Is it here? Now next please. So what? H to S. And you just come back. Go school to and found that you come back. Is it here? So what is it saying here? 3 kilometers. You found that school was closed, came back to your home at 7:45. So your first time is what here? 6:30? Yes, AM. And next is what? Second time. What is the second time here? 7:45. So can you tell me how much time you stay in the span in the journey? Exactly, del T, or also you can represent by time interval. Del T is the time interval, means part or piece of time that you have spent during the journey. Is it? Some by different way, different books, different people write by different way, right? This is the del T, means change in time point. So how much is that here? Obviously, what is the gap between them? Here it is 14 minutes, 15, is it? And here what leaves? Tell please. It is bigger. So 5, 5, 4 minus 3, how much is what? 5 minus 0, 5, and 4 minus 3, 1, and 7 minus 3, is it here? How much? It is 1 hour, you will write here, 1 hour what? 15 minutes. 1 hour 15 minutes he has spent here. Is it? This is the total time taken in the journey. So now we are to find out total distance traveled by you. So therefore total distance. What the total distance? Total distance. Distance total we are to find. What is that here? Length of path, he goes from his school, home to school and come back to, means double of the journey has traveled, kilometer. Can you tell me what is this? 6 obviously. Similarly, we are to find out displacement, total displacement. So whenever you are telling the total displacement, think its initial position and final position during this time interval. What is initial position? Home. What is final position? Again home. Obviously, what the answer here? Please tell me. 0. The change position 0. Have a look the next. A body is moving along circular path. A body is moving along circular path. A body is moving along circular path of radius. Same I am saying you that. This is circular path. Is it or not? Center. A body is moving on a circular path. It starts journey from A. Suppose we are considering the point A is. A body is moving along circular path of radius r. Its radius is r. Got it? Its radius is r. What will be the distance and displacement of the body when it's complete half revolution? Yes, situation ko picturize, do this picturization of that. Here you will do. It will just, here it is from that. Half the journey means he just reached at B point. Is it enough? So we can just give here the direct line approach here. This is means he has completed the journey from A to B, half the revolution. Is it here? So we are to find out its total displacement. Again, we are interested in finding the total distance and displacement. So can you tell me what the distance and displacement? First is distance. What the distance is here? Length of path. And what type of path is here? A to B, sir, and it's a curve path. Is it here? So tell what is the half the semi-perimeter, half the perimeter of the circle? Sir, the complete perimeter of the circle is 2 pi r. Means 2 times pi r. If he starts journey from here to here, it's called 2 times pi r. So what about half? Sir, 1 time pi r. Is it or not? That is 1 time pi r. It's this here. This is its distance. Okay. Now second, displacement. What about the displacement? Displacement, he just start from A to B. Direct distance is to be taken here. That's A to B. Got it? So what about A to B? Sir, A to B is passing through the center. So from A to O is the radius, and here it again radius. How many times radius? 2 times radius. This is called diameter. Got it? It is this. Hope you understood. So diameter of the circle here is the displacement. Now we have learnt by different numericals activity what is the distance and the displacement. Is it? Now some skill test questions that we have to do in that. Have a look at the first question here. Define the distance and displacement. Could you define this here? Second, is displacement scalar or vector? Do the meaning word scalar and vector. In the previous lesson here, in the same question in that, if the object will complete its journey here, start from A to come back to A back, is it here? So what will be the displacement? So displacement will be what here? 0. If obviously I'm telling this here in this, A to B is traveling, A to B, and again A to B is going first, okay, and again coming back B to A. So tell please B to A. So what is this displacement? It's becoming 0 here. So displacement is getting a fraction. Displacement is getting influenced by the direction. Is it here? If you will not come back, your direction will not be from B to A. So same distance you will travel further straight ahead. Is it here? Your displacement will not be 0 here. Your displacement will be double of that. But in case of coming back, your displacement will be 0. Means there is the effect of direction on the displacement. But there is no effect on the distance. Like your motorcycle, when you ride motorcycle for means you are going for a restaurant for purchasing something else, right? For buying some and come back to your home. What does your odometer tells? Means what does milometer, what you call, that is speedometer. It's a speedometer, no? It's milometer. Okay, that measures the distance traveled by a rider, milometer. So your milometer tells your distance or displacement. Sir, obviously distance. If it were tell displacement, then ever it will make 0. We'll just go to the restaurant, somewhere, schools, office, right? It will make positive, and I come back to that here again. It will make some this 0 here, right? So they makes the displacement. Sorry, distance. Is it here? So distance does not has the effect of direction. So a physical quantity that does not have the effect of direction is called vector. Scalar does not have the effect of direction are scalar, and have the effect of vector are called vector. Effect of direction is called vector. Got it? Right? Now come on please. Give an example of motion in which distance is covered but there is no displacement, motion moving along the circular path. An ant traverses the boundary of a square, speed floor on the side. You will just solve this question as an assignment. Okay? Please take over that. Question number 4 will be as an assignment. Now class assignment 2, numericals. See on that? A cycle moves with a speed 18 km per hour. A cycle moves with a speed 18 km. What is its speed in meter per second? Means conversion of unit I am talking about. Obviously speed here given 18 km per hour. What is the meaning of this word 18 km per hour? Means 18 km in 1 hour. Before that you must know what is the speed and what is the displacement. Oh sorry, velocity. Is it here? I'm just will explain you this later. So here this is to be converted into meter. So multiply by 1000. Now the entire quantity becomes here meter, and this is to be multiplied by what? 3600 second. Now it's become second. Is it? So here 2020 will cancel out, and here 2 5s are sorry, what will here is? Here 18 2s are 36, or 18 1 is 18. Here leaves only what? 5, and here is what? 18 2s are and 1. What? No, sorry. Wait please. Here it is. 18 multiply about 1000. Now it's become what? Or here it is 3600. What does here? Second. So 20 get cancelled. It's 18. How much? 18 2s are, or 18 1 is, and 2 1 is, and 2 5 is. What's coming here? This 8 1 5 meter 5 meter per second. So I will suggest you, this is for a specified particular question. I am telling for one. How much meter per second in 1 kilometer per hour? The same you will do this. How much? 1 में इतना तो एक से ज़्यादा में कितना, that you can check this. Is it here? That is this. 1 kilometer per hour, that is 1000 multiplied by 3600. It's a meter, it's a second. So 2020 cancel. Here it's what? 18, or here it is a 5. 2 is common factor. Here it will be 5 by 18 meter per second. This is the coefficient that if you want to convert kilometer, suppose x kilometer per hour is to be converted in dot 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 meter per second, then you will multiply this x by 5 by 18 and then it will become in meter per second. But if you want to convert meter per second into kilometer per hour, then you will multiply by 18 by 5. Is it 18 by 5? Then it will become kilometer per hour. Is it or not? Is it? Now look the next. Here it is. So we are just talking about the speed and the velocity. What do you understand by the speed and velocity? Speed and velocity. So what is need to know the speed and velocity about here? It is the motion variable of the motion velocity. Suppose that we have observed here the two types of motion right now, like that the journey of the car here, car A, or here it's what? It's B. Got it? Both are moving at different aspect, right? Suppose that we made the tabulated information about both here. It's the time. They start journey at 9 o'clock. Car A, and here it is car B. Is it all? So what here? 9:15. Sorry, it's a 9:05 minute, 9:10 minute. Here 9:15 minute. Here 9:20 minute, and so on and so on. Position of car is at here, suppose 0 they have started, or already they have some position at 0, and this also at 0. After some times its position was at 5 kilometer, this was at 7, is it? And here it will be at 12, and here it will be at 15, and here it will be at 18, and here will be at 25, is it? Furthermore, here it will be at 20, and here will be at 29. The different reading we took here is about the motion of both the car. So if I want to tell you, so one thing just come here, that it is, what is the distance traveled? 5. What is the distance traveled? How much distance traveled here? 7. What is the distance traveled here? 6. What is the distance traveled here? Tell please. Here also 2. What is the time lapse here? 5 minutes. Here about the time lapse here? 5 minutes. Here the time lapse here? 5 minutes. Here also 5 minutes. So in 5 minutes it is traveling distance 5. Is it, or in 5 minutes it is traveling distance 7. In next 5 it is traveling distance 7, or in next 5 it is traveling distance 8. In next 5 it is traveling 6, or it is traveling 7. So when you observe the pattern of both the motion, then what you conclude? Sorry, we conclude that car B is in the motion faster than this here. Is it here? So how can we measure the fastness of the car B? So there needs to know some more quantity here. This. So the measure of the fastness, how fast the car B is moving. Is it here? Because it's moving in 5. Within 5 minutes, it's moving 7. So we can say that here, the car B is moving in 5 minutes this much, and this one is 7. How much is this moving? 5. So you will see that here, it's a car A moving 5 kilometer within 5 minutes, it's 7 within 5 minutes. Again, in next 7 within 5 same, in 8 within next 5. Is it here? So here it is. Furthermore, we'll make the calculation for that. What about this? It's 1 kilometer. Here it is what here? 1.4. Similarly, here what? 1.6. Here again same. We can speak here. It is traveling 1.4 at, we can speak here at the rate. total 7 kilometer, 8 kilometer is traveling in 1 hour, 2 hour, 3 hour. So it is, sorry, it's in minute. It is traveling 1.4 kilometer in 1 minute. So a new quantity just come in mind right now, that is called the velocity. So the rate measure of the fastness, how fast the object is moving, this is called velocity. To write here this here, the measure of how fast, measure of how fast an object moves. The measure of how fast an object moves is called speed or velocity. Is it? Numerically, how can we find out here? This is equal to ratio of, what we can say here is the distance okay, distance traveled in 1 minute, sorry, in unit time. The word unit time, why I am using unit means what? It can be 1 minute, 1 hour, 1 second, 1 day, whatever, right? In unit time is called what? Is called distance, is called speed. This is called speed. And similarly, the distance traveled, the displacement travel, to write here is, I am stating here is the distance traveled, displacement, okay, displacement in unit time is called velocity. Now we have to make differentiation between these two, okay, between these two physical quantity. Here speed and here it is velocity. In 9th standard, this question may be asked in examination as point of difference between speed and velocity. Is it here? So this will be your home assignment. Please will appreciate here this. Is it here? Thank you. It's nice day. Your assignment of the day is class assignment 2, numericals, right? From the question, do you have the soft copy of that, right? From the question number 1, 2, 3, 4, you will solve that. Okay.